The iron in your blood was created in the final second before a star exploded. The calcium in your bones was forged in a stellar furnace that burned for billions of years before the sun existed. The oxygen you're breathing right now was produced inside a star that lived and died before our solar system was born. Your ancestry begins in the deep interior of these ancient furnaces. Tracing the origin of your body requires going back to the time before those stars existed. We begin with nebulas. These are vast, freezing clouds of formless gas and dust drifting through the dark. Over millions of years, gravity acts on these quiet clouds. It pulls the scattered hydrogen together, compressing the gas until it forms an intensely dense, superheated sphere. As the sphere shrinks, the internal temperature reaches a breaking point. When the pressure is high enough, nuclear fusion triggers. This is the moment of ignition, the birth of a star. Earth represents the universe assembling the heavy machinery required to eventually build human biology. This diagram shows a star's main sequence, a violent balancing act. Gravity tries to collapse the star, while nuclear fusion pushes back, maintaining a stable sphere. Zooming in, the star smashes simple hydrogen atoms together, manufacturing helium to resist gravitational collapse. A star's mass determines its lifespan. Massive stars burn through their fuel in just a few million years, while smaller stars like our Sun burn steadily for billions. Every second a star burns, it acts as a ticking clock, converting basic fuel into the first complex ingredients needed for the universe to evolve. When the hydrogen fuel is exhausted, gravity wins the struggle. It squeezes the core until it reaches the temperatures required to start fusing heavier elements. This is the onion model of a dying star. The core develops concentric layers of fusion, sequentially creating carbon, oxygen, neon, and silicon. The carbon layer here provided the source for your DNA, and the oxygen manufactured the molecules entering your lungs. At this stage, the star has successfully manufactured the biological ingredients for life, but they remain trapped inside a massive gravitational prison. Low-mass stars, like our Sun, solve this by swelling into red giants. They gently shed their outer layers into the galaxy, leaving behind a white dwarf. This shedding process is the primary delivery system for the carbon and oxygen found in our biosphere today. High-mass stars continue fusing heavier elements until they create iron. Iron is the limit of this engine. It absorbs energy rather than producing it, which stops the fusion process instantly. Without fusion pushing outward, gravity crushes the core in a fraction of a second. The material hits the center and rebounds into a supernova explosion. The intense pressure of that explosive second is the only environment capable of forging the iron pumping through your veins. This violent death is a biological requirement. Without the destruction of the star, the chemistry of life could never be distributed across the cosmos. The debris clouds from these stellar deaths drifted through space for eons. Eventually, they cooled and collapsed to form our specific solar system. You can trace a single iron atom from a supernova shockwave as it settles into the Earth, is pulled up through the roots of a plant, and is eventually integrated into your own blood cells. Your body is a temporary biological arrangement of atoms that are already billions of years old. Humans are the result of these ancient processes, experiencing a brief window of conscious life. In 5 billion years, our Sun will repeat this cycle. It will swell into a red giant and swallow the Earth. This death will take the atoms making up your body and scatter them back into the vacuum of space. Those atoms will eventually hit new gas clouds, trigger new collapses, and build new stars and planets. The atoms you use today will go on to build entirely different structures in the next iteration of the cosmos. Every atom of carbon in your body was forged in the core of a dying star. Every atom of iron in your blood was created in the final second before a supernova explosion. You are an expression of the cosmos, assembled from the debris of ancient stellar explosions, arranged by chemistry and time into something that can look up at the night sky and recognize where it came from. Subscribe to Stellar Abyss. Every Tuesday and Friday, we go deeper. The next video is already waiting.